Get them live on YouTube too? Alright. Hey everyone. Hard luck. Thank you for the 5 bits before I even went live. The bad lad. I should have thought about this in advance. I don't have anything waiting on me in the Discord to answer. Oops. I clicked on something to mean to. Maybe I'll just go directly over to studying. Yeah, I guess let's do that. Wait until someone comes in chat with a question. I don't know why my initial instinct is to always start scrolling. And I don't know why, because that would take forever to get down here. Wasn't I looking at one? And thinking about it last stream? I don't think I was that far down. Ooh, I think it was 11. That's not what I meant to do. Okay. E4 aligned from a cutoff potential. So we want to calculate the potential. What's up, Jed? I think so. I would love it. So if we want the potential of an infinitely long straight wire, told Mrs. Jen that you might get left. Depends if Mrs. Jet agrees or not, I guess. So I think we want this bad boy. I always have issues kind of applying this formula with whether this R is related to the X prime, Y prime, Z prime. And I think it's... I think we get it treated like a constant. I think I did that the last time I did a question, like the last time I was doing this. And it turned out okay. 6-dimensional tesserine. I don't know, corrupt. Incoming! Figured out the algebraic form of it? Oh, okay. Zach. Thank you very much, Zach. Nice stream. Wait. Isn't this the exact question that I was about to do? Yeah, I will be interested to see how that project develops, Zach. And I'm still interested in doing that project. Oh my god, I can't talk. That Project Euler challenge. If you want to talk more about it, I feel like we just need to like set a date or something so it lets it fire under me. But if you're still interested in that, I'm absolutely still interested in it as well. Hey, SBQ. And that's interesting for corrupt. And so I assume the challenge with that is that it's not a power of 2, so it's a bit more challenging to create that. Whoop whoop. But yeah, so for anyone be new around here, my usual shtick is I take homework questions from chat, and I sometimes look around on the internet, but if things are still like they are now, I just kind of do some studying, or just chat, to be honest. But so right now I'm doing some electricity medicine studying, and I was just looking at a problem like down in the exercises after this chapter, but it seems like this example is the exact thing that we wanted, so I'm trying to figure out why it's not, or why it's different. So it's also now thanks to diagonalized matrix form. Oh, okay. Oh, okay. So the key difference here is they're doing it from a finite point to another finite point. You have no life. The 60 streak. I appreciate it, Jed. Thank you. Hey, Poonam. Please permutation A? I don't know what that means. Asking about like permutation problems? Been around the clock. Ugh. Eventually, there have to be a number high enough that you'll run out of puns, right? Gotta see what that limit is. We're talking big hand, yeah. Only 9 more to go. If it was possible to do alerts for those watch streaks, I would absolutely like want to do one for 69. I guess I think we're gonna do the same integral, but we're gonna be going from infinity to something. It's quitter talk. All right, so here's a problem that I've been looking at, number 11. Yeah, I'll keep the second paragraph in there. It's going to be a big old box, but that's okay. Yeah, this chapter of the electricity magnetism has had such cool math concepts. I already forgot the integral that we're going to want to do, but too late now. In chapter 2, we've something that I never learned about, something I learned a little bit about, but it's dealing with like curl, divergence, gradient, in the context of electricity magnetism, and just like I just love how it uses the calculus to like combine all these different concepts and relate them. So the potential is going to be the negative integral coming out from infinity. And are we going to do an arbitrary point r? Really? Oh, last I checked, stream elements doesn't do it. But maybe there's a different thing that can. And I also haven't checked stream elements in a while. Why is my chalkboard white? Because it's a much better version of a chalkboard. And all that is what you say when you want to sound smart, but you don't know, what else to say. We found E using direct. Okay, so it was lambda over 4 pi epsilon naught r, I think is the field due to an infinitely long wire. I want to, since I have the memory of a goldfish, I'm going to scroll back up quickly and look at that integral. We can have the same vote from Tuesday on your whiteboard, just to be fair. That's true. The vote in your chat, I'm claiming is rigged. Wait. Whoa. Okay. Stop the presses. They do even more work with an infinitely long wire? That's not the... Okay. Hey, Sabi. Yeah, this is some studying that I've been doing while there aren't like homework questions from chat. Okay, so the field outside, rho a squared over 2 epsilon naught r. Let's go at the other example first. Where? Eventually I'll find it, I'm sure. I feel like I just passed it. Yeah, I definitely just passed it. Here we go. Okay. Lambda over 2 pi epsilon naught r. That's the field due to an infinitely long wire. Glad I checked that. Okay, so let me just write it down on the whiteboard quickly. Just correct my work, 2 pi epsilon naught r. Now, where was that other one? If two conducting sphere and another sphere is infinitely social, what is the potential of it? I'm really sorry, Puna, but I'm not sure what that means either. It's conducting sphere inside of another sphere, or two spheres side by side maybe, or... I'm pretty new to all this, so if it, like, I wouldn't feel comfortable like really answering questions on this, so I'm not really sure what you... I guess I'm not sure what the question is, though, either in the first place. Oh, this is for finding the divergence of an electric field. This is not related to what we want to do here. I have Laplacians as well. Stokes theorem. I need to go back and study these vector fields again. Which one have zero divergence? Which ones have zero curl? Which when I was doing this the first time, I felt very confident in my answers, and then I was like completely wrong. So I feel like I need to take a fresh look at that one, or like reread it on divergence and curl. Okay, so consider the field E due to an infinite straight wire with uniform linear charge density lambda. So I think we're going to go from infinity to some arbitrary radius away from the wire R1. Oops. You had one of the curl ones wrong? Oh, I don't think I probably got it like 20% right, I think. It was something pretty abysmal when I tried it. So I'm just gonna make it go up to R1, I think. And that R1 will change into a regular R later. So in front here are all constants. We only really care about R. ln R from, oh, don't forget the minus. And the problem here is ln of infinity. Sad. It diverges. I wonder why we don't just accept that as reality. Because I guess we should intuitively know that it doesn't diverge, but like the fact that this does diverge seems kind of like an issue. Maybe because it's infinitely long, and we're going to get a different electric field for the second part of this problem. And in reality, you never do have an infinitely long wire. I don't know. Get around the simple by instead finding the potential due to a very long but finite wire of length 2L at a point lying on its perpendicular bisecting plane. So (2L) perpendicular bisecting plane. Use a Taylor series to simplify your result, and take the derivative to find E. So we need to figure out, wait. Isn't this, aren't I doing this backwards? They asked us to find E using the potential, but I already used E in my formula for the potential. Something's not, I think I misunderstood a part of the problem. So I just did this formula when I should have done this formula. Okay. Because they asked me to find E, and that formula clearly uses E, and I just blindly used E. But we have to use this, I think. Now, this seems weird to me though, because aren't we interested in x prime, y prime, z prime outside of, like, it's not going to be 0 outside of where there's charge, the potential, but isn't rho 0 where there's no charge? Oh, no. The x prime, y prime, z prime this is just getting the total charge. The x, y, z for where the potential actually is not prime. Okay. So yeah, this integral only exists to integrate over the density with respect to volume to get the total charge. And in problem 11, we just have a linear charge density and we have a length of the line, so we don't really need to do an integral for that. So let me redo the first part, but do it the right way and not just the, cheating way where you already know what the field is. Ah! I just flipped my mouse over, sorry. Eldritch, hey! How's it going? So the potential I want to redo the case for an infinitely long wire because I'm supposed to do it from scratch and not from already knowing the electric field. If it's infinitely long, aren't we going from minus infinity to positive infinity of lambda I guess like dy if we want to say it's along the y-axis over 4 pi epsilon naught r, where r is some constant distance away from the wire. That's what I'm thinking now. Four pi epsilon naught r. Let's see what this gives us. It's still like, the important bit is that it's 1 over r, and we're going to end up with ln of infinity. Well, ooh, no. Why is this integral so weird to me to set up? Because this will give me a diverging integral, but I feel like I haven't set it up right. Maybe it is right. I don't know, but maybe that's why once we go to a finite wire, things will be okay. Zero minus L, 0 positive L. Like, can I just take that same integral, but go from minus L to plus L? Lambda dy 4 pi epsilon naught r? Just see what this spits out. No, they say you need a Taylor series approximation. That you don't need an approximation for this. I feel like I just still don't understand the formula for potential. How we actually apply it. Okay, so actually I think I'm getting the right result. Maybe I do understand, it just doesn't feel right. Okay, let's just keep it going, I guess. But actually, no, the Taylor series part. Why isn't it just 2L times lambda, the total charge, divided by 4 pi epsilon naught r? Riddle me that. Yeah, sure, Esperanto, feel free to let me know the question. I'm gonna look at the answer. I feel like it doesn't fembox. That's my... Like... Because my interpretation of, like, this formula here with the is that you... Like, this x, y, z in the R are definitely related. But this x prime, y prime, z prime only have to do with the charge density. Actually, do I even want bounds? It's R is a function of x, y, and z, I think. That's why I get so confused about this. I mean, you might be right too. It's just like it's not my understanding, at least. Okay, here they do. Wait, why? I don't know. I need to cite this example a bit more, but Aspirant posted their limit question, I see. So let's take a look at that. So you have the limit as n tends to infinity of 1 cubed plus 3 cubed plus... Let me just copy on the question onto the board. Okay. Sounds good, Fembox. Okay, so... This is an interesting type of problem. I don't know... why they would want you to do this, or I don't like where this would come from exactly. It looks a little bit like it would come from a series, but even then, it's not quite the same. I think a normal trick here is I see we have if we think of these as like polynomials, this is like a degree 3 polynomial on top. That's a degree 4 polynomial on the bottom, because n squared is n to the 4th. So what I want to do is from the top, factor out an n cubed. And so everything in this series is going to turn into 1 cubed over n cubed plus 2 cubed over n cubed plus 3 cubed over n cubed plus 4 cubed over n cubed plus ... plus 1. And from the bottom, I'm going to factor an n squared out from the inside here. 1 over n squared. Oops. 1 plus 1 over n squared. Importantly, this square is still on the outside here. But since these two things are multiplied, we can basically distribute this exponent to the 1 over n squared into that parentheses there. So let's do that. The numerator stays the same. I'm just going to not write as much of the numerator to save time. That's 1 over n squared, which is 1 over n to the 4th. And then that 1 plus 1 over n squared gets its own square now. Oops, I forgot to write the limit. That should be there. Oh, that's probably a better way to do it, aspirant. Really? Is that the formula? I thought it looked a little bit different. Let me look it up. Is the square of the sum to n? Oh, okay. So that is the formula. We should do that then. Okay. I think my way is valid as well. But that's a more direct way of doing it. So yeah, if we do the formula for the sum of cubes there, it's n plus 1 over 2 squared over n squared plus 1 squared. That gets rid of the arbitrarily large number of pluses, at least. Let's distribute that square to the n plus 1, and to the 2. Two squared becomes 4. There we go. I don't like this fraction of a fraction business, so I'm going to bring the 4 down. You tried using that, but you got stuck? This will be possible to evaluate. I think you're going to need to use the trick that I just used. Or that I was about to use that other problem that I'm going to use again now. So already I look at this and I see on top, just looking at the degrees of the top and bottom, we have an n squared and times another n squared. So that's degree 4 on top. On the bottom, we have an n squared squared. So that's degree 4 on the bottom. So the quick and dirty trick is that you can take the leading coefficient of the top and bottom, and that's your limit. So it'll be 1 over 4 is 1/4. But we can actually prove that too. And here's where you would want to do factoring. So I'm going to pull an n out of this parentheses here, and then square it out. Well, here, I'll show it like this. I'm going to pull an n just outside of this part in here, so we get n 1 plus 1 over n, parentheses squared. Can't forget about the square there. From the bottom here, I'm going to do a similar thing, but an n squared because we have n squared there. Similarly, there's a square on the outside still. Now that squared can get distributed to the n and the 1 plus 1 over n. That squared can get distributed to the n squared and the 1 plus 1 over n squared. So we get n squared times 1 plus 1 over n parentheses squared over 4 times n squared is n to the 4th. 1 plus 1 over n squared squared. Okay, and we're nearly there. On top we have n squared times n squared is n to the 4th. N to the 4th divided by n to the 4th cancels, or it's just 1. So what we end up with is 1 plus 1 over n in parentheses squared over 4 times 1 plus 1 over n squared squared. Now we're ready to plug n goes to infinity. 1 plus 1 over infinity is 0. Or, I'm sorry, 1 plus 1 over infinity is 1, and 1 squared is just 1. We have a 4 times 1 plus 1 over infinity is 1 plus 0 is just 1, and 1 squared is still just 1. So we just get 1/4. Oh, I'm sorry if it was a little bit too small. I usually don't, don't have that problem. Are you watching in a low resolution or something? If you want, keep posting them. The next one, I'll try to write it bigger. I don't have brown, no thunder. I have orange. That's the closest. So, like, even looking at the figure for this one, like, R doesn't, like, the x prime, y prime, z prime, I guess is like your origin for R, which maybe that's what you have to adjust for. The distance from x prime, y prime, z prime to x, y, z. Okay. Me, but as a stump. And I can still try to make it work, but yeah, it would be like orange or red or something. I don't know what me as a stump would look like, but so maybe it's for the better they don't have a brown marker. Okay, this is probably what R is equal to this thing. And so yeah, I would need to split this up into, I guess, a bunch of dy's. Similar to how they did this potential for a disk. If at is a repeated root of ax squared plus bx plus c, moment as x tends to at. Oh, alpha. Okay, sure. What a funky question. Oh, I see that. Okay, yeah. That's kind of a neat one. if alpha is a repeated root of ax squared plus b x plus c, then we're interested in the limit as x approaches, alpha of sine of ax squared plus bx plus c over x minus alpha squared. And so the thing to remember here, oh my god, not infinity. Alpha, is that if alpha is a repeated root of ax squared plus bx plus c, that means that you can rewrite ax squared plus bx plus c as x minus alpha squared. That's what it means to be a repeated root. So I'm going to apply this to the what's inside of the sign there. So we end up with sine of x minus alpha squared over x minus alpha squared as x approaches alpha. Now, oh, the a in front? Ooh. You're right, Fembox. We do need that a in front, don't we? That's going to make it a little bit harder. I think we can deal with it, though. I shouldn't have written it like that. That's a good catch, though. Yeah, we do need the leading coefficient there, so we don't know that a isn't 1. We can still deal with this, though. What I'm going to do... Yeah, so this is looking a lot like... I hope what this makes you think of is the... I'm just going to like a well-known limit with well-known in quotes. Sine of x over x as x approaches 0. And this is known to just be 1. So I want to do anything it takes to make this look like that. And the thing that I think is going to be helpful is a change of variables. I want to make the substitution u equals, I guess what's inside of sine, a times x minus alpha squared. And that means as x approaches alpha, u approaches a times alpha minus alpha squared equals 0. So now we know everything we need to apply this change of variables, because we have to know what to change the limit to and what to change the inside to. So now we're going to get the limit as u approaches 0 from that, what I just did there. Sine of u over, now this is, there is no a here, so we do have to say 1 over a times u. And that's okay. Like I'm basically dividing the a over here, so it's just x minus a squared for the denominator. 1 over a is just a constant. It can go out in front of the limit. And it's actually, it's 1 over a in the denominator, so it's going to get flipped up to the numerator and go out front. So I'm going to say a times the limit as u goes to 0. Sine of u over u. And that now we can use the fact over there that it's just 1 to get just a. That's kind of cool. I like that problem. Multiply and divide by alpha. Oh, there maybe is some kind of trick like that too. You've been teleported? Hey, Waffle, yeah. Zach rated out. If we multiply and divide by alpha, get the form and the answer will be alpha. I don't see how that works, but you might be right. I just don't know. Like, where are you multiplying and dividing by alpha? If you have a different way that works, it makes more sense to you, then just go with that. This is the way that makes sense to me, but... I can draw that thunder, yeah. Depending on your definition of can. Add your own spice using that image as inspiration. Let me show the image that Thunder sent me. Me as a stump. How beautiful. Yeah, I completely agree, Waffle. Can you please explain why you multiply by alpha in the repeated root? Oh, sorry, that's just an A. It's not alpha. So this right here is just A, same as that's also just A there. And that's because there's a leading coefficient on the original polynomial, or the original like quadratic. So we do need to keep that as it gets factored. Adding in my own spice. Should draw a family portrait of the Twitch math community. Oh, that would be amazing, Waffle. I would love to see that. Wait. It's gonna end up looking like a Pac-Man ghost. Ah! Don't do a hard corner like that. It's not very stump-like, right? Okay. Get all those like wood like lines, I guess. I don't know what I'm doing with all that stuff, but be careful of the light and bigger. And that's already plenty big, and it's not in the way of the light. It's fine. I was about to draw like down there too, where my cam would block it. You know, I feel like you should count your blessings here. How's that fair? All right, fine. I don't see how it's in the way of the light, at least on the OBS preview. I'll make it bigger, just to make you happy. So freaky. I don't like that root. It creeps me out. Dude, why is drawing this so hard? That looks a little better. I don't know, maybe I do want the hard corners like that. Add freaky root back. Oh my god. You're being really controlling, Thunder. I'll add the freaky root back, I guess. Why do I have 60 FPS cam? Hopefully because it looks better. All right. There's a freaky root. Sure. Like something like that. Just random lines, I don't know. Draw off the end of the quadratic curves, it'll look better. Oh, like these like lines? Just use your fingies, it's much more exact. Shit, screw rid of that. Okay, there. Yeah, it's a little better. Make an art class so this talent can be honed. You know, Waffle? Yeah, I'm gonna need that. Art class. All right, Aspirin, I see your next question. Just let me do this little like drawing here before Thunder, like, I don't know what the Thunder's gonna do, but they sound serious. He said to add my own spice, so I have an idea to add my own spice. Just wait. These eyes are intentional. Just have a full on, actually, the red beard looks stupid. I have an orange marker. Why am I doing red? All right. And I'm getting all sweaty because wait for it. Bam, an axe, you know? It's not good. Even though I'm already stumped, so what does an axe gonna do to me? That hasn't already been done. Not the baseball bat. Alright, let me start erasing the math problem so we can get working on aspirant's next limit. It just erase the physics too. It's all wrong. Okay, limit as x goes to 2. (2x squared plus, oh wait, no, 2 to the x. Hey Jellybean, how's it going? 2 to the x plus 2 cubed. If you're still here, can you confirm if I'm writing this down right, aspirant, as I'm writing it here? Minus x minus 6 over 2 to the negative, oh, 2 to the power of 3 minus x. Okay. Um, 2 to the negative x minus 2. Or x over 2. Minus 2 to the 1 minus x. What is going on with this problem? So I guess just to get a feel for it, what's stopping us from plugging in 2 directly? We get 4 plus 2 is 6, minus 6 is 0 on top, over 1/2 minus 1/2, so we get 0 over 0. Technically, L'Hopital's would apply. I don't imagine L'Hopital's is going to be particularly helpful here, though. Because when you take the derivative of an exponential, you just get the same exponential back times a constant. So I'm not a big fan of L'Hopital's. I think they use some algebraic manipulations. And what I want to try first is on the bottom we have a 2 to the negative x and a 2 to the negative x. What happens if we factor that out? Well, no, that's actually, we can't really factor that out, can we? The x over 2 messes that up. The answer is 8? Okay. Oh, is that a, are you Jellybean at aspirant? Let's write a little neater. Okay, the next thing I want to try, or well, I guess the first thing I'll try, because I haven't actually tried anything yet, is multiplying by 2 to the x over 2 to the over 2 to the x. So this is just 1. But my thinking here is that we'll get a little bit of cancellation in the exponents with a minus x and a plus x and a minus x and a plus x. So that might clean things up. Let's see. So 2 to the x times 2 to the x is 2 to the 2x. 2 to the 3 minus x times 2 to the x. The x's add to 0, so we get just 2 cubed. Minus 6 times 2 to the x. Over 2 to the minus x over 2 times 2 to the x is 2 to now the positive x over 2. Write that a little bit bigger. That minus x plus x becomes 0, so it's just 2 to the 1. This might be something that we can plug 2 into and not get something bad. Hey Jaden, the problem is what's written at the top of the board. You're not jelly? Oh, okay. Sorry, you two wrote like the exact same like answer as 8 thing, so. Yeah, Jellybean, I don't think LHopital's helps here. The derivative of an exponential isn't going to really change all that much. So I plug 2 into this thing. What happens now? We get 2 to the 4 is 16 plus 8 is 24 minus 24. So we still get 0 on top. We still get 0 on the bottom. So, I mean, of course, I should have known that. But, oh, this is... That's like a quadratic on top, isn't it? Wait, LHopital's does help? Isn't d by dx of 2 to the x just 2 to the x ln 2? How does that help? Unless I'm mistaken on that, but... I'm curious about this factoring thing. 2 cubed is 8. Minus 2, because that does factor, and with it's like a quadratic. Even if there's a better way, I just want to see if this way works. This would factor to be minus 4 minus 2 for 2 to the x over 2 minus 2. Oh, we nearly get a cancellation. Maybe LHopital's does get rid of some of the cancellations because of the chain rule. So I should give it a better try. Oh, wait. Yeah. No. There probably is an algebraic way to do this. I don't know how factoring 2 to the x minus 4 works. Oh, I see. Okay, yeah, difference of two squares. I am going to explore the L'Hopital's way after this. Since I'm already on this train of thought, I want to see if it actually gets an answer. So yeah, if we treat that as the difference of two squares, it'd be x over 2 minus 2, 2 to the x over 2 plus 2, 2 to the x minus 2, 2 to the x over 2 minus 2. So those two cancel. So we get 2 to the x over 2 plus 2 times, oops, 2 to the x minus 2. So that's what? 2 to the 1 plus 2 is 4 times 2. That is 8. So this does get the right answer. But L'Hopital's is probably, it sounds like it's probably simpler. So let's branch off the problem, follow a separate train of thought, and apply L'Hopital's. 2 to the x derives to 2 to the x ln 2, 2 to the 3 minus x, the negative for the chain rule, 2 to the 3 minus x ln 2, the 6 goes away, chain rule, get a minus 1/2 in front, times 2 to the minus x over 2 ln 2. That minus flips to a plus because of chain rule, 2 to the 1 minus x ln 2. This actually cleans up. The ln 2 is all cancel, I guess. We have that going for us. Minus 2 to the minus x over 2 minus 1 because of the times 1/2. Plus 2 to the 1 minus x. If we plug in 2 here, does everything cancel still? 2 squared is 4. Minus 2 is, so we get 2 on top. On the bottom, we get negative. Two over 2 is 1. 2 to the negative 2. Plus 2 to the negative 1? I feel like I did something wrong. Clean if you let u equals 2 to the x. Yeah, I mean, I could do that change of variables too, but to me it's not that unclear, but 1/4? A half minus a fourth is just a fourth. It does give 8. Wow. Okay. So L'Hopital's, it's a lot more direct. The way in blue, you have to find a lot of tricks. I like both ways though. So I guess, yeah, thanks to the chain rule, L'Hopital's actually is helpful, which is not what I thought would happen. Oh, Waffle, is that your cat? Or is that just a random cat? Either way. That is adorable. That is your cat? Okay, this cat needs to be seen. Waffle posted this in the Discord. He lost the worm in that picture and decided the stick was a fine toy. I was about to ask what he was chewing on. Aw. That's another toy just like, oh wait, is that the worm? Okay. It's fair enough. I feel like cats prefer like the weird toys that aren't actually toys. Jellybean, I graduated a few years ago with a bachelor's in applied math. It's a little worm on a string on a stick. Oh yeah. When I had cats growing up, we had like a little like it didn't look just like a mouse, but it was basically a mouse on a string on a stick. I think they intentionally don't make the mouse look too realistic, so it doesn't like disturb the humans. If f of x is differentiable and strictly increasing, ooh, be funny if they did make a really realistic cat toy. Makes like squeaks of pain as the cat like. I don't know. It always kind of weirds me out with like pet toys in general, which is like, you know, the dog or the cat is basically trying to like kill it, but it looks cute because it's just a toy. Okay. So, the answer according to the textbook is -1. Okay. As x tends to 0. Place is already looping? Ugh. New playlist. There. F of x squared minus f of x. This is going to be a LHopital's. Okay. So first off, what happens if we try to plug in 0 directly here? We get f of 0 minus f of 0 is 0. We get f of 0 minus f of 0 is 0. We get 0 over 0 in determinate form. LHopital's applies here. And we're able to apply it because we know f is differentiable. Importantly. So we do have to do chain rule on that one. So the derivative of x squared is 2x times f prime x squared minus f prime x over f prime x. F of 0 is just a constant, so I think that goes away. Yeah. And now what happens here? We get where 0 times f prime 0 minus f prime 0 over f prime 0. And because f of x is strictly increasing, the derivative is always a positive number. What's more important is it's not 0, so we're not dividing by 0 here. So we have 0 minus f prime 0 over f prime 0. So the f prime 0 is, let me just write in a second step. Negative f prime 0 over f prime 0, because that's just 0 times anything is 0. Since f prime 0 is not equal to 0, we can cancel them and say it's negative 1. Take f of x equals e to the x. Oh, yeah, that's a neat trick, Ansh. You could name a function that fits the bill and try the question with that just to figure out which multiple choice answer you would want on a test. So yeah, f of x equals e to the x would certainly work. Yeah, get some water. That was the wrong hotkey. Okay. um. Okay. As we wait for another question, let's go back to electricity magnetism stuff. See, I think this example is one that I should be paying more attention to for... I think I know how to set things up. Or I feel like I know a bit better how to set things up. Essentially, they don't have a cosine theta here, though, or a sine theta. Yeah, sure, Waffle, please do. Aspirin has another limit question as well, I see. Limit as x goes to 3 pi over 4. I need to replace the ink in this marker. I have spare ink available, I just need to actually do it. One plus tangent of x to the 3 over 2. So I'm interpreting that as the x has a 3 over 2 power, not the tangent. Please correct me if I'm wrong there. Over 1 minus 2 cosine squared x. Oh, it is on the tangent? Okay. Minus 2 cosine squared x. So potential is scalar. Yeah, that's what I was thinking, Fembox. That's why you probably don't need the cosine theta. So just as a little sanity check, what's preventing us from doing 3 pi over 4 immediately? Tangent 3 pi over 4 is 1, negative 1. So you get 0 on top. Cosine of 3 pi over 4, I assume is going to be it's going to be 1/2. So we do get 0 over 0. So I'm thinking LHopitals. Okay, yeah. And you're asking me to do that too. And hey, oh my God, I forgot what you told me I could call you. Was it Jordan? I'm so sorry that I forgot. Joseph. Okay. Well, I was 2 letters correct. Joseph. I'll try to remember that. Sorry. Okay. So let's do LHopitals on this. How's it going, Joseph? Taking derivative of that, we do the power rule first. Chain rule, derivative of tangent is secant squared. It's going to become a positive because of chain rule. Or cosine x sine x. And we know that secant is 1 over cosine, right? Just to kind of group things up a bit more. Two times 4 is 8. Cosine cubed x. What do we get here? We get negative 1 times 3 is negative 3. This might actually just work. Sine, that's root 2 over 2. Cosine cubed, we get negative root 2 over 2 cubed. This is just going to be a number that we can figure out. So this is like 8 times minus root 2 to the 4th over 2 to the 4th. Multiplying this root 2 over 2 into there, just to make the cancellation a bit easier. The negative signs on top and bottom can cancel. 3 over 8 times 4 over 16. The 8 and the 16 can cancel. 4 and the 2 can cancel. 3 over 2? Is that our answer? Just finished self-studying the first half of Calc 1. Ooh, that's exciting. Negative a third? No! Let's check out my derivatives. And I see that wall. I'll take a better look at it in a second. Actually, let me do them one at a time. Root x secant squared x. That's fine. or sine x cosine x. What the hell? Did I mess with my fraction math? Wouldn't be the first time. Or did I mess with my unit circle, maybe? Oh, wait. I said tangent of 3 pi over 4 is -1. I square rooted -1 and said it's still -1. How does that work? Tangent of 3 pi over 4. Oops, it is -1. But it's the square root of tangent. How do you deal with that? Yeah, this isn't, what don't you like about this Desmos? Use parentheses. Hardlocked, thank you for the 69 bits. Ugh. This function isn't defined. Here. Let's give over off of the limit as well. I think it's not a well-formed question from the book. As you say, aspirant. I don't... I want to give over off the limit just to confirm. But... Oh wait, I'm not showing my browser. My bad. I've been looking at this thing in Desmos. Yeah, you get a you can do it from the left and you get a complex number. Oh no, it's a complex number times infinity. Yeah, it's not a well-formed question. Okay, and so Waffle. It's one of the tips most uncomprehended textbooks without spending 5 years on them. Most of your math is competition-based math practice. So I have them tight deadlines, you know, like 90% comprehension. So anyway, study tips, if any, are appreciated. Studying from a textbook. It is kind of challenging because like one of the services that like, you know, a teacher would do is distill the textbook down to the most important bits and just give that to you and do it on a regularly scheduled like thing where you're expected to show up. And if you're just self-studying from a textbook for your own reasons, or, you know, like without the guidance of a teacher, yeah, I know. It depends if you're like if you have a specific aspect of it that you're having an issue with. I think maybe like the most general advice is try to use outside resources also. Like if there's a specific issue where the textbook's explanation doesn't make sense, like look for other explanations online or something like that. But I think that's kind of like an obvious thing to say. It does help if you can like do like what like me or Pinson have been doing and like get like a group of people together who are also interested in studying it, and that can help like you know, you can put questions to the group and get to an understanding together, and also it helps like keep you, like, like keeps a fire lit under you to keep on going with it. Yeah, I think that like just like the best approach you can take is doing some research on a textbook that fits your needs, but then regardless, also using some outside input to keep some perspective, I guess. So if you use servers for it, it's just a matter of understanding one question. It's like 30 minutes investment for 3-minute competition questions. Yeah, it's kind of a difficult thing because memorizing formulas. Yeah, I hate memorizing things. I avoid as much as I can. It feels like this is a version of like how can I learn faster, and that's just kind of difficult to answer. Because my usual kind of response is you just need to grind it, and um a textbook is probably going to be like, I imagine it'll be more verbose than you need for like competition math. Like if there is some other resource that like distills it down more, that's probably better, but I don't know of a way that you can like, if you're supposed to do a problem in 3 minutes, but you don't know the trick to do it, it probably does just take time to learn that trick. I don't really know of a way around that. Like when I first learned something new in math, I almost never immediately understand it. I need to spend time thinking about it and applying it before I actually feel like I understand it. And usually for memorization, it's like if I use the thing enough naturally, I'll remember it that way. And if I don't use it, I just kind of like, I don't really like do flashcards or anything like that. I just, if I use it often enough, I'll remember it. If I don't use it that often, then I won't remember it, which maybe isn't the best thing. But no, competition math might be a little bit of a different like beast that I've never done any type of competition math like that. I actually have done one competition in my life, but it wasn't like speed. It was more of like a project. So I don't really have any experience with the competitions like I think I've seen you studying for. So yeah, I'm not sure if there is some kind of resource out there that's more distilled down and not as verbose as a textbook probably is, then that's like the best thing that I can think of. But I'm not sure what better advice that I could give. I'm sorry. I see Aspirin posted another question. Ooh. I'm not sure what to do with that question, Aspirin. I'll think about more in a second. Matter of pure grinding. It probably is waffle, at least as far as I know. Unfortunately. And hey Zane, you finished all your 3 papers for your math GCSE. Oh, nice, and it went well. Paper 1 is a little difficult. I'm not sure if I got a grade 7. Paper 2 was definitely better. Paper 3 was great. Awesome. Congratulations, Zane. Yeah, Joseph, I think the one on the board is just bad. Okay, XYZ, you can post the question once. You don't need to spam it. Um, Zane, I'm sorry, not Zane. Aspirant posted their question first. I'm gonna look at Aspirant's question, and then XYZ, I'll look at yours. So Aspirant, you said if g of x is absolute value x minus 1 plus absolute value 4x minus 11. So, well, modulus anyway. I don't know what that means, XYZ. The number of points of discontinuity. We want how many points of discontinuity there is in the interval 1/2, 5/2. The greatest integer function. Huh. Well, I don't know why we would care about the top at all. We can just look at where the bottom is 0. That's still going to be tricky. Or x minus 11. Oh yeah, I happen to read it as greatest integer function anyway, XYZ. It's all good. Greatest integer of x squared minus 2x minus 2. So I think the top can be whatever it wants. The only time we're gonna have a discontinuity here. Ooh. No? Maybe not. This absolute value maybe could have a jump on top. I want to graph the top function. So I'm having a hard time wrapping my head around it. It's not division, it's multiplied? Oh, I missed that. Thank you. I inserted a slash in there that you didn't actually write. I still don't know how to do it off the top of my head. Do you see the trick, folks? I'm trying to figure out if this absolute value is going to have a jump when something flips from positive to negative. No? It does get a little bit crooked. Yeah, okay. I was worried there might be like a gap where it gets crooked right there, but I guess not. The second function. Oh, okay. We just need to figure out how many times the second part breaks, I guess. Which maybe just plug in the endpoints. And that's our problem. Okay, so this first thing here, it's continuous. We're not going to get any answers from it. The second piece here, it is going to be discontinuous though. So let's just work on that. And because of the way the greatest integer function works, I think we can figure out how many integers are on this interval by plugging in the endpoints and seeing what the actual values are. That's kind of my thought. Pretending there's no like greatest integer function around it. So if we were just about x squared minus 2x minus 2, and we let x equals 1/2, what do we get here? 1/4 minus 1 minus 2. Minus 11/4. Which is, actually decimals are better here, aren't they? 2.75. And then at the end, 5/2, we get 25/4 minus 5 minus 2. That's 7. So we get minus 3/4? Does that make sense for a parabola? We should get something bigger here, shouldn't we? Oh, it depends what side of the vertex we're on. Maybe it makes sense. The vertex is at x equals 1. The greatest integer function is the floor function? Oh, I got that mixed up. Thank you, Zone. When I heard greatest integer, I was thinking rounding up, but I think you're right. It should be the floor. Because it's the greatest integer that's less than this thing. I guess yeah, it is supposed to be floor jet, I guess. I misunderstood that. I think there might be a way to do it in decimals. I can't remember how though. These numbers don't seem unreasonable to me since the vertex is at x equals 1. And so how many integers are we going through along this journey here? So the floor function basically chops off let me for 1/2 5/2 minus 2 point, well, if. Yeah, we need to actually, yeah, we do have to care about the vertex. Okay, so we need to check the endpoints, and we also need to check the vertex of this thing. Fenbox completed the square for us. X minus 1 squared minus 3. So what we have, if this, ignoring the floor function there, is something like that, just a little part of a parabola there. I should probably draw a little bit bigger. It's literally just floor parentheses. Oh, okay, Jed. Let me draw that a little bit bigger, though. X equals 1/2, x equals 5/2. And so the number of discontinuities is going to come from like each transition from one integer to another. So is the floor of a negative number, is this going to, I think it's going to be -3, the floor of minus 2.75. So that means if we take the floor, this is, over here, this is x squared minus 2x minus 2. And then over here will be the floor of the same thing. We start at -2.75, and so if we floor it, we go down to -3. And we stay at -3 until we get to x equals 1, where we've hit our vertex, and now we're going to start increasing. Check my Discord. All right, I'll look at it in a second. Oh, yeah. And now I'm not sure exactly of the lengths involved here, but I don't think we need to care about it. But basically, it's going to look, they're going to get shorter and shorter, but we care about going up to 5/2, which is 2.5. The floor of this thing is -1. So we go from -3 to -2 to -1. And we don't go anymore because we know we don't go past 0. So I think we have 3 discontinuities. And we know that because we checked the endpoints and we found the minimum value, which is the vertex here. And so based off that, we can kind of construct approximately what the graph looks like. What's with the X in the tree stump? Someone over on Twitch, on Twitch I have like redeems for people to make me draw things, and that's what someone redeemed. Is it? I think no, because we go from -3 to -1, right? So there's a oh wait. There are, yeah, I guess it's only 2 discontinuities. You're right. I was thinking there's 3 steps, but technically there's only 2 jumps between these steps. You're right, Finbox. Thank you. I think Jed plotted this in Desmos. Let's see. So yeah, we have the interval 0.5 to 2.5. Oh Oh, and so the blue line is the parabola floor that I, haphazardly drew. And the black line is the actual product. And so in both cases, we see the number of discontinuities are the same. Thank you, Jeb. So yeah, Aspirin, I'd say your answer there is 2. It's a pretty difficult one to analyze. Hey, Anders. And so XYZ, are you still here? I'm able to look at your question now. Yeah. So it's actually kind of a similar question, funny. We have another greatest integer function. Find the domain and range of the function. The equals to -3 part is actually kind of weirding me out. Let's look at the graph of this thing here. Yeah, because it's a question from JEE Advance. Okay. Because if it's equal to -3, it's not really a function. It's just an equation. Second tough exam in the world, geez. Whoa, what is this thing? Oh, Despo's just having trouble drawing it. So there are solutions for it being equal to -3, but it's not always -3. So is this exactly how they gave the problem XYZ? Because this doesn't make sense to me as it's stated. I can maybe try and guess what the meaning is. But it's like you wouldn't say something's equal to f of x and equal to 3 at the same time. You could find when this function is equal to -3, but you want to say it's always equal to -3. It's exactly the same? Well, then I'm going to give 2 different approaches then, because this just doesn't make sense as it's stated. So I'm going to do one where I ignore the equal to -3 and just find the domain and range of this. And then we'll do a second version where we find where this thing is equal to -3. I don't know if that simplification works, Anders. The domain of this thing off the bat, it's just all real numbers. Because we're allowed to plug anything we want in here, but the range is the more interesting piece. So So we're dealing with floors here. So 2 sine x at its absolute best could be 2. Exactly 2, and the floor of 2 is still 2. Cosine x at its absolute best could be positive 1, and the floor of 1 is still 1. So in theory, this thing could be 3, but they're never going to hit their maxima at the same exact time because they're like out of phase with each other. The best these are ever going to do is 2 because their peaks are just never going to line up. I would say that the maximum for our range is 2. The minimum for the range, at worst, 2 sine x is -2. But importantly, because this is floor, things between -2 and -1 still go down to -2. So there's a lot of opportunity for this to be -2, which is not true for +2. Same with cosine. The worst it can be is -1, but anything between 0 and -1 will get floored down to -1. So I think we can take the worst case of both scenarios here pretty safely and say that the minimum range is -3. Because we don't have to worry about their peaks aligning. We don't have to worry about the values aligning. -5 to +5? I don't know how you would get that. And actually, looking at the graph on Desmos, I just think that's wrong. Because it definitely goes down to -3. Root 5 is the amplitude of the wave if you don't floor anything. Oh, okay. Oops, shoot. I just like stumped my cord a little bit. No, I think the answer is -3. Actually, when does this hit 2? It definitely is the minimum -3. I'm not seeing it actually hit 2 though. Which is a little concerning. I don't know if this one just isn't drawing it quite right. Because like that vertical bar does reach up to 2, but I don't want to read too much into that. How do we justify that it never gets up to 2 either? It's like, never getting up to 3 seems pretty clear to me, the way that floor works. Cross multiply root 2 and use... I don't know what you mean with that, Jaden. Madeira, I have no idea what that means. Only at a single point, x equals pi over 2? Oh. And Desmos would miss that, I guess. At pi over 2, sine is 1 and cosine is 0. Ah, okay. Thank you, Phobos. Intro to logic improves. I'm not very strong on that. All right, so I think we can say the range is -3 to +2 because Fembox, it's they start with the same sound. The names. -2 to 2? No, aspirin. It definitely goes down to -3. At x equals pi/2, it does hit 2. So I think the answer for this interpretation of the question is right. But there was like a second piece of the question, which I'm still not exactly sure how to interpret the question, but where does this thing equal -3? Which we haven't figured out. I mean, I haven't figured that out yet. So the only time this thing is equal to -3 is when 2 sine of x is less than or equal to -2 and cosine of x is less than, no, strictly less than -2, and cosine x is strictly less than 0. These have to both be true at the same time. So I think we can solve these two inequalities separately and figure out our intervals. That's never true. Wait, what? Oh, sorry, no, strictly less than -1. Because anything less than -1 gets floored down to -2. Ugh. So -0.5. There we go. Can I prove 2 + 2 = 4? Not without using a calculator, I guess. Oh, okay, that's a nice way of doing it, aspirant, yeah. I wrote the range as an interval. Is it not supposed to be an interval? A finite set? Maybe it's technically wrong, but I feel like that's how I usually would say it when I was just doing my algebra classes and stuff. I mean, it doesn't have to hit every number between -3 and 2. It certainly doesn't hit every number between -3 and 2. I feel like for when I was first learning this, though, we just didn't really care about that. So I guess I'm making that same assumption, but... But yeah, if we solve this, x is less than or equal to the arcsine of -1/2. Well, on a sine curve, we're interested in that bit there. It should... so we want the quadrant 3 and quadrant 4 values. It'll start at the quadrant 3 and end at the quadrant 4 value. Where's sine ½ -1/2? At pi/3 plus pi, which is 4 pi/3, plus 2n pi less than x is less than 2 pi minus pi over 3, 5 pi over 3, plus 2n pi. That's where we're valid for sine, at least. We still need to work out the cosine part of this. We got 2 requests for series on JEE Advanced questions and SAT questions. I don't know if I'm going to do a series like that, but if someone has a specific question, I'll answer the specific question, but yeah. Capture both. So where's cosine negative? I could draw a circle. That's just not how I think personally, though. We want that area down there, so we're going to start probably in quadrant 2 and in quadrant 3. That makes sense, I guess, because where cosine is negative. So cosine starts being negative at pi over 2, right? Plus 2n pi less than x less than 3 pi over 2 is where it turns positive again. Plus 2n pi. And we need to take where these two intervals agree with each other as our overall answer for where this thing is equal to negative 3. And their only overlap is between 4 pi over 3 plus 2n pi and 3 pi over 2 plus 2n pi. So I'd say the answer to this question here is 4 pi over 3 plus 2n pi is less than x is less than 3 pi over 2 plus 2n pi for any integer n. And that's all the domain, or that's all the ranges for x that give you that negative 3. Pi over 6? Oh my god, Fanbox, you're right. I messed up my unit circle. Ah! Thank you. I just can't do math. Sorry, it starts at pi plus pi over 6, which is 7, no? Yes? 7 pi over 6. And it ends at 2 pi minus pi over 6, which is 11 pi over 6. And this first part of the interval gets changed. Okay. I just messed up my unit circle there. Ugh. Your goofy cat? Oh gosh, okay. See, I hope that helps XYZ. I guess I haven't seen you type anything in a bit, but for the two interpretations I have of that question, those are the two separate answers. Teratar, I think we agree then, yeah. I did initially make a mistake with the 7 pi over 6 part, but Yeah. All right, we do have a drawing request from Waffle. Let me bring up the image of Waffle's cat. Desmos. Yeah, I have the Desmos output up here already. 3.67 about. What is 7 pi over 6? 3.66. I'd say that's pretty close. Up to 4.71. 3 pi over 2. 4.71. Yeah. Yeah, the range part of that function is kind of tricky. Or sorry, no, you weren't talking about the range. You're talking about the 3 part. Whoops, that's not what I want. What am I? Oh yeah. Okay. This is Waffle's cat. We gotta draw him. What I just want to say we, I mean me, but okay. Can I go for the same pose? Let's see. You know, his neck kind of blends in with his body in this pose, so I guess I'll... go for the same thing. Gotta have to fill in some details where the blanket covers things up. Yeah, cat. Got green eyes. Kind of like green yellowish, but the closest I have is green. I mean, that looks kind of weird if the outside is green. There we go. Hey, Casey. What kind of math is this? It's the best kind of math. Ah. Kind of like vampire teeth. Oh god, the black marker is dying. Oh god, this is going to look terrifying the way that this is going to come out. Let's draw first. Let's start with this paw that's coming out in front. Okay. I feel like that could have gone worse. That's so pointed. Oh god, that looks like a butt. Or that looks like something else. God. Imagine the cat's tail is curled around there. Okay, we gotta get like the markings or like a gorgeous so far. Oh, awesome. Glad to hear it. Hey, Ved, I see that question. I'll do it in just a second. Yeah, it's one of the channel point redeems. Has a little sock there. Like a little like tuft of black fur up in the middle. Even goofier. Awesome. Almost like a... I don't know what that reminds me of. Like the cat is like, there's like cut up of the white fur to black fur, it's like somewhere around there, and like, I don't know. He does have a good amount of ear fluff. We should get the ear fluff in there. Looks a little bit like ear piercings, but you know, what can you do? I don't know. Ta-da! I don't know what else to do with it. It's a little gremlin-y. The right side of the tail, the marker was really fading. That could be a little bit darker. You love it? Okay. Glad to hear it. Black? Oh god. I gotta switch out the ink in this marker. I don't know if I'll be able to do that one, Anders. I'm sorry. So I have to do Ved's question here, and I want it to be legible. I'm gonna give you your points back. Okay, so Ved wants to know the domain and range of x minus 4 over 4 minus x. After the stream, I'll switch out the ink in that marker. Hard luck. I know you too. Can you have the cat next week? Oh, that's awesome. Oh, you know what? This one has a kind of a cheat. Well, this one requires a little bit of care here. So we want the domain in the range of this thing. So for finding the domain, the only issue that I can see here is x equals 4, because in the denominator, we're going to end up dividing by 0, and that's no good. So I'd say off the bat here, we don't want anything involving x equals 4. But this thing, it kind of cancels. So we can write, from the bottom, I'm going to factor out a -1. Yeah, so if x were to equal 4, the denominator would be 0, so we have to throw out x equals 4. But from the bottom here, I see a little trick that we can do. I'm going to factor out a negative sign. So that flips the sign for each of these, so we get x minus 4. And wouldn't you know it, we have x minus 4 over negative x minus 4. That cancels. 1 over negative 1 or just negative 1. But we still have the restriction that x can't be 4. That's important to remember. So this function is always negative 1 no matter what you plug in for x, except we're not allowed to have x equals negative 4. So I would say the domain, this can be written in many different ways. I'll write a few of the different ways. You could say negative infinity up to 4, not inclusive, union 4 not inclusive to positive infinity. You could say all real numbers minus just 4. You could say x is less than 4 or x is greater than 4. There's many different ways that you could write the domain of this. It depends on the class and the context that you're in. The range of this, from what we found here, is just always negative 1, no matter what. Where it's defined at least, which is not 4. So that makes sense. Let me know if you have questions. It's a letter like that, like I, that allows imaginary division by 0. That's a good question. As far as I know, there isn't. In calculus, you learn about the idea of approaching 0, and you might be able to divide by something that is approaching 0 and getting very close to it, but not actually 0. I think it's kind of the closest thing that I can think of. But I don't think it's a full-on, like, other world of math that involves the wonders of dividing by 0 in the same way there's a whole world of math that comes with taking the square root of a negative number. I might be wrong, but... Awesome, bed. Glad to help. Okay, is there any question from chat? Let me know. If not, I'm going to go back to doing some studying. This should be because basically making this coin disappear. Like it'd be relevant 200 years from now. I feel like someone who's studied math at a higher level than me will be able to give you a better answer, because I'm thinking, like in complex variables, I think there's something called like a pole, which is where a complex function is undefined, and you kind of look at behavior around that. And that undefined could be from dividing by 0, I think. And I think in general, there's a thing called like 0 divisors that like are kind of talked about like generally in types of math that people study. Like, so I feel like if someone who's like has a higher level of math understanding than I do might have a different answer than what I just gave. But yeah. Do I know about the Hydra game? I don't think so. No. Hey, Bachelor Club. How's it going? Cloud? Okay. Sounds good. So it's a good stain sequences. Yeah, Cloud. So like the theme of the stream is I take like homework questions from chat and I sometimes look around for them on the internet. But if things are still like they are now, and there's a question to work on, then I just kind of chat with people who are around, or I do some studying. A number file game about the Hydra, or a number file video, I assume? I wouldn't know. Cut down the Hydra to its root. Cut off one of the heads, after which the Hydra grows new heads according to the following rules. Oh, interesting. When is a head not growing out of the root? What is z equals z squared plus c? I don't... Like, is that a quadratic that you're supposed to factor? I don't understand the question, Cloud. I don't think. And I see VOD posted another question. You see notes, you immediately noped? Yeah, I don't know anything about this. Mandelbrot? Oh, I don't know anything about it. Wow, lived to what, 86? Not bad. Anyway, I don't know anything about what you're asking, Cloud, but VOD posted this question. I'm not sure how I'm going to do it, but it feels achievable. Oh, and Cloud, if you're interested, you know, I tend to kind of stick to like early undergraduate level math because that's what I know, but there are many math streamers out there on Twitch. So if you're interested in more, and there are people who can discuss it, that kind of stuff better than me probably, there's a whole list of people who stream math that I can like recommend. I don't know about Mandelbrot sets specifically. I just I don't know anything about that exact thing, I guess, so. And I'm not sure who in the list would know, but yeah. I don't know, there's some more people out there, though, if you want to... If you're interested in math streams in general. Yeah, Phobos. Trying to get, like, EnigmaBot to update, it's like, I feel like we need to, like... It's gonna be, like, a process, but I figured I'd just use my own list in the meantime. Yeah, I mean, it's long overdue, Phobos. And sorry, Red, I'm still thinking about your question. I'm still not really sure. We're adding even powers of I? Huh. This feels like induction or something. I feel like we need to look at some cases. Yeah, I sort of, for now, I'm just gonna like manage my own list of like people for the chat command, so it's... I feel like we don't need to like get an agreement from everyone to like modify the shared list. So we have 1 plus I squared plus I to the fourth. I seem to wrap my head around, I guess, how this pattern works. Oh, awesome, Joseph. Thank you so much for the kind words. I should say one of the Twitch streamers is planning to start streaming on YouTube. I'm not sure what his first day might be tomorrow, but I'm not sure. He'll be back soon. Okay, no worries, Phobos. Let me get you the link there in case you're interested in another YouTube stream. Over on Twitch, he's e to the 2i pi. On YouTube, he is Coverstone Corner. So at some point, I think in the very near future, he's going to do his first stream over on YouTube. I'm not sure exactly when. Okay. So I want to look at like just some specific values of this. So I squared is -1. I to the fourth is +1. I to the sixth is -1. So looking at partial sums, if n equals 0, we get 1. N equals 1, we get 0, because 1 plus -1. If n equals 2, we get +1 plus 0 equals 1. N equals 3, we get 1 plus -1 is 0. So we're only ever going to get ones or zeros here, it seems. And what were our options for the answers? Positive, negative, 0 cannot be determined. Well, I guess out of the options available, we would say cannot be determined. Because it could be either 0 or 1. We could say it's definitely not negative, but that's not an available answer. So I think cannot be determined is the best choice available. Is 1/2 an answer choice? I mean, I don't imagine 1/2 would be, I think about like the average of it. I don't think 1/2 would ever be an actual answer. Cloud, if you know the answer, feel free to shout it out. It's backseating welcome here. Zero? How would you know that? Yeah, but when it comes to like helping someone out with a math problem, like, and I'm doing something wrong, I absolutely like want to know. Yeah, I feel like my little thing here has proven that it just alternates between 0 and 1. I don't know how you would ever know that it's just one of those things. Wait, do French people say that 0 is positive? That's all sorts of wrong. I said that feels wrong. I don't know. I guess you can still make. consistent math with that definition, but like it just feels so wrong. N is either odd or even. So I mean, I think the fact that n is odd or even means that we don't know what it is. If n is what, odd, we know it's 0, but if it's even, it's 1. Bully all your friends learning French. The answer is D. Okay, yeah. Yeah, I agree that D is the right answer. Do you feel like you know why? Because I think the simplest way to do this question is to just try a few easy values for n here. And we see it's never really gonna... It's not really an actual proof that we've done here, but it's never gonna really be... It's just gonna always alternate between 0 and 1. So for an arbitrary n, you can't say what it's going to be for sure. Unless you want to do... Well, I mean, not with the options they gave you, anyway. Rigorously prove it. It probably actually wouldn't be that bad. You could do a proof by induction and do a separate proof for even n and a separate proof for odd n. But I think maybe there's mathematicians that say induction isn't rigorous, like it doesn't count. I don't know about that. Some of the exercise for the reader, exactly. Yeah, Claude, we definitely can say more about like the series of numbers here, but for the options available, the only one that makes sense is D. So I think it's as hard as we need to think about it. Yeah, if you, Ved, or anyone have more questions, feel free to put them in chat. So what's up with this Hydra game? You cannot lose. That's my type of game right there. I still don't know how the game actually works. Like, I assume for this rule, it's out of the root means directly out of the root, so like that one right there. How to regain sanity? I wish I had the answer. For me, probably like drink some coffee or something, I don't know. So they cut off that head. Delete the head and its neck, descend down by 1 from the node. Wait, what? You cut off this one head and 6 more grow back? I don't get how this works. I just grow 2 more heads. And the real answer is probably therapy, but you know, just watch the number of... Oh, okay. I see you have a question from Ayush. X squared plus x squared over x plus 1 squared equals 3. Find x. Okay, we can do that. It doesn't just what you were looking for? Oh, dang. X plus 1 squared equals 3. Okay. We need to solve this for x. So immediately, we're not allowed to have any solution where x equals -1. If we happen to solve this problem and we eventually find that x could equal -1, we'll have to throw it out because -1 plus 1 is 0, and we can't divide by 0. That breaks math. So with this caveat, let's now go about doing some algebra here. The immediate thing that I don't like here is that we have a fraction there, and we can get rid of that fraction by multiplying both sides of the equation by the denominator. So my first step here, it's going to multiply the left by x plus 1 squared and the right by x plus 1 squared. So the x plus 1 squared will get distributed to each of these terms. And for the second term, x plus 1 squared will cancel with x plus 1 squared. That's the entire reason that we're doing this. So what we end up with is x squared times x plus 1 squared. And then, like I said, this will get canceled over here, so we get just x squared from the top. And then 3 times x plus 1 squared. Did you finish your chicken tendies? No! Oh, that's how it works? You cut off one node from 3? Huh. That's kind of crazy. This is going to be a pain, isn't it? Is there a trick here? I think we just have to multiply everything out. I don't see an easier trick here. That's unfortunate. Okay. Well, I don't see a way to proceed other than multiplying out this x plus 1 squared and that x plus 1 squared, so let's do that. X plus 1 squared becomes x squared plus 2x plus 1. Everything else is the same. This x plus 1 squared, we can reuse our same work from right there. X squared plus 2x plus 1. Now over here, let's multiply the x squared inside the parentheses. So x squared times x squared is x to the 4th. X squared times 2x is 2x cubed. X squared times 1 is x squared. So that plus x squared there. On the right side here, we get 3x squared plus 6x plus 3. Now let's take all of these, subtract them over to the right, or to the left side, to get everything on one side of the equation. So the 4th plus 2x cubed. X squared plus x squared is 2x squared. 2x squared minus 3x squared is minus x squared. Minus 6x minus 3. What do we do with this thing? Do we have to rational roots that? I think there's... You move x squared to the right and take the square root of everything. We're still gonna have a radical somewhere in there, I think, Waffle. That might not be a bad idea anyway, because this is such a pain. Well, this might not actually be too bad. I hope you know rational root theorem. I'm gonna get this problem to Wolfram Alpha 2, so I wonder if Wolfram Alpha finds a trick that I don't. There's not that many cases to check here if we know the rational root theorem. And the rational root theorem says that the roots of this thing are going to be the leading coefficient, which is just 1, times the constant and all the factors of that, positive and negative. So we just have a 3. And the factors of 3 are 1 and 3, so our potential candidates are plus or minus 1 or plus or minus 3. And we already know that x can't be -1. So we really only have 3 cases to check here. That's not so bad, and they're pretty small numbers. I normally try to avoid using rational arithmetic if I can. A simple and elegant solution with completing the square? Oh, let me, Simple and elegant solution with completing the square. Yeah, I feel like it definitely does seem like there's some kind of trick here. Completing the square? Where would you complete the square here? Right there! Probably. We want everything to have an x+1 squared, I guess, right? Okay, if... x squared... Oops. If we have an x squared, and we want to get an x+1 squared, I think that must be what the trick is. We could do -1 + 1. Maybe we can settle for just x+1, I guess, rather than x+1 squared. This will make it a little bit simpler. So x squared minus 1 is a difference of 2 squares. Becomes x minus 1 times x plus 1 plus 1. I don't know, I feel like this should be a better trick, but we could divide out an x plus 1. We've already thrown out x equals -1 as a potential solution. Then we get a denominator there, though. So how does that help? Is there a better completing the square? Oh, is the music coming through on YouTube, Daniel? It's not supposed to, but at least on Twitch, they should be able to hear some synthwave music that I'm playing. I usually have the Twitch, or I'm intending to have the Twitch play music and YouTube not have music. If I miss something with my audio, though, it's absolutely possible. You hate these kinds of problems? They can definitely be annoying, but if someone needs help with it, I'm gonna try and help them. Came from music playing on the Twitch side? Okay, that's good to know. Ooh. How do you get that, Wolfram? Teach me your ways. From the initial version, I might see it. Okay, let's I think you complete the square on the initial problem. I think maybe you do a plus or minus 1 thing up here. And then you can do the same difference of 2 squares. Let's see how it turns out. You still get a denominator, though. Like, this becomes x squared plus x minus 1 over x plus 1 plus 1 over x plus 1 squared. Like, is that really helpful? I'm still missing the thing, I guess. Well, we're not that far from what Wolfram had, though. We could rewrite this as x squared plus x over x plus 1 minus 1 over x plus 1 plus 1 over x plus 1 squared equals 3. Like, these are pretty dang similar. What if we combine these two things? Get a common denominator. That's a minus in front, so it's 1. It's x plus 1 with a negative. It's 1 minus x plus 1, so you just get I feel like I've gone off the rails here. I don't know. Huh. Substitute y equals... Oh shoot, I missed out on some YouTube chat here. I don't know how you get to that, Joseph. You subtract the 3 over and get a common denominator for everything, or I don't know. What if we add and subtract 1 inside the square? That could be it. Or Daniel substitution might be it. Oh, from like that initial line to up there, factor out the x plus 1 squared. Well, no, but that plus x squared messes up your solution there, though, I think, Joseph. It's not just necessarily root 3 or negative 1. It could be negative root 3 too by that logic. But the plus x squared, I think messes that technique up anyway. Factor out x plus 1. All right, I'm kind of curious about Ayush's idea of doing the plus minus 1 inside of the x squared. So instead of x squared, what if we had x plus 1 minus 1 squared? I don't know if it's going to make a substantial difference, but I just want to see. X plus 1 squared minus 1 squared is plus 1? So you get x squared plus 1 over x plus 1 squared equals 3. Ooh. That seems like something. Oops, equals 2. Is this easier to solve directly now? The way that I was trying to do it up there? Oh shoot, I didn't drop the cam. Divide by the denominator to get 1 minus... Oh. What is 1 plus 1? 2. Oh, I didn't factor that right. Shoot. I made a mistake. When I brought the squared inside here, I wanted to basically treat x plus 1 as a unit and the minus 1 separately. So like that's one number, and expand it like it's a plus b. Or I have to distribute the square, but I needed to actually expand this like it's a plus b squared. So what we get if we did expand it? X plus 1 squared minus 2x plus 1 plus 1. What happens here? We get x squared plus 1 minus 2 over x plus 1 over x plus 1 squared equals 3. You might have found it? Ooh, okay. I have no idea what that means, Ved. Cosine 75 degrees plus I? Oh, you're doing like complex numbers there? That's probably best converted into would you want to do rectangular or exponential form there? Oh wait, that's a weird. I don't know how you dealt with the exponents there. 30 to the a? That's not the degree sign, Ved? Because the first one is 75 degrees, but the next 3 angles are like to the power of a? Because I really don't know how you do that, I don't think. What a tricky problem. Oh. Huh. I guess that's true, Joseph. I don't see how that's helpful. I think Waffle may have found the trick. Let's Let me bring this up. And then game advantage, but it's not bad so far. What's happening from the second line to the third line? Did you square root everything? Because I do like this idea. Maybe let's run with the idea, because like this is a clever way of factoring it too. Just like compensating for the part that we're missing. I feel like the trick here is taking more time than just doing it the hard rational root theorem way, to be honest. But if there's a trick here, I want to figure it out. I think what Waffle was doing is looking at, if we just took all the squares off of that thing and had to square it out here, what would we get? X squared plus 2x squared over x plus 1 plus x squared over x plus 1 squared. But we don't have this. We are like, these two terms matches that. So if we subtracted this piece over, we could say that this thing is equal to that, which might be helpful. We may end up wanting to take the square root of each side as well. Like, is this easier to solve? Perchance. I don't know, like we could add this over and take the square root of each side. I don't think we're helping. Could I multiply each side by x plus 1 squared? I think we're going to get back to a quadratic in that case, which isn't going to help. Is it on Discord? Okay, sounds good, Joseph. I'm not sure where to go with this. That is a neat trick. I don't know where to go with it, though. I see Ved posted a different complex number question that I think I can get done quickly. If x plus iy is equal to root 2 plus, or root, wait, the square root of 1 plus 2i, like that? Or is the entire thing square rooted? Like that. Maybe I don't know how to do that. What is the square root of a complex number? The question is, what is x squared plus y squared squared? Well, it's the entire thing. It's a fraction. I don't actually know how you deal with that. I'd have to look up how you deal with... Oh, it's a fraction? Oh, I missed the divide sign in that. Oh, I guess you could put it into exponential form and take the square root of that. Let me look at what Joseph sent. I'm pretty sure the answer is supposed to be 1, 3, or -3. So, actually, let me... No, wait, never mind. I did some... Oh, there aren't rational roots to that quartic that I got. Oh my god. Isn't that the golden ratio, by the way? That first one, I think? Or no, probably the second one. Okay, fine. Wolfram just doesn't want to give it to me. So I'm just like switching between problems right now, but you add 1 to each side. Oh god. You get a common denominator for these. Wow. That is crazy. So from this step, you did x plus 1 minus 1 on top to get this thing inside the parentheses. You expand this thing out. Huh. Yeah, I did not see to do this from the steps that you were saying. This is really clever, Joseph. And it does seem to get the right answer. It's Wolfram improved. Nice solution. Yeah, I think this works. I don't see anything wrong with it. That's the cleanest way that... There's like a few like tricks in there, but I can't come up with a cleaner way. And these roots are not rational, so my whole rational root theorem thing is not gonna work. That's clever. Thank you for posting that. All right, let me get back to the complex number question. I feel like that red is a little bit too light to read. Let me switch to blue. And the person who asked that question, if you want to see it if you want to see me pull up that solution for longer so you can get a screenshot or something, just let me know. Okay, so it doesn't make the play here is to put these into exponential form and then root it after. One plus 2i. So the radius is root 1 squared plus 2 squared, which is root 5. E to the I, the angle is arctan 2. Is that unit circle? What is arctan of 2? Is it possible? Oh, wow. It's just not even unit circle. Okay. I'm going to keep it as arctan 2. It's not a clean angle or a clean... It's not a clean angle in radians or degrees. 3 plus 4i. That's radius 5. Angle... I feel like I should know this, but I don't. 4 over 3? A 3, 4, 5 right triangle. Maybe it doesn't have a well-known angle. Arctan 4 over 3? Yeah, I think that's just a... You can keep it as arctan, I guess. So I don't think that's a clean number either. But if we have the square root of each of these, square root of root 5 e to the I arctan 2, square root 5 e to the I arctan 4/3, we get 5 to the 1/4 times e to the I arctan 2 over 2, or 5 to the 1/2 e to the I. This is so messy. I think there should be a simpler way to do this. I think maybe we can think about how that's squared. Ooh. No, I don't know how you... Is x squared plus y squared equal to x plus iy conjugate squared? Is that the rule that we need to use? And then we have another squared on the outside? Using wavy curve method? I haven't heard of the wavy curve method, I'm sorry. Take modulus and square it. Does algebra give anyone else back pain? Yeah. Gives me all sorts of pain. Well, the issue with squaring each side's teratar is that the left side, x plus iy squared, is x squared minus y squared. That's why I'm bringing conjugates into the mix. The question is, what is x squared plus y squared squared? What I wrote on that line 2? Like, if we're given the first line, what is the value of line 2? And so what I tried to do is just directly evaluate that square root business, but it's kind of messy, and I think there's a trick here that's a lot more clever. I'm not very good with complex variables, though, or complex numbers. Yeah, I'm from the USA. I think there's some identity with conjugates that I'm just not aware of that's helpful here. Your brain isn't braining anymore after that last one? Yeah. So maybe we can make the argument that is it to do something with this? The moduli are the same for the conjugate and its not conjugate. Square root x squared plus y squared. Wait, Ved, weren't you the one who asked the question? Do you already know how to solve this? I got to make a variable for x plus y and then cry. uh. Or Ved, if you already know how to solve this, then I'm just gonna drop it because do you already know the answer, Ved? Oh, I mean, what do you need from me then? Like, do you understand the problem? Because if like I try to work on questions that people don't like that they need help with, but if you already like know the answer here, then I'd rather move on to a different question. If there's stuff that you don't understand in the solution, then like I'll try and work it out. But if you understand it, then I'd rather just move on. Am I crazy? Isn't x plus iy squared x squared minus y squared? Or wait, no, you get a... Yeah, I don't know. By squaring both sides, we get an x squared plus... Oh! Oh, Territar, you are separating IC. Okay. I was getting confused because x plus iy squared isn't directly x squared plus y squared, but you can still work with that. Shouldn't it be x squared minus y squared though? Okay, yeah, and Fenvox got that system of equations. All right, well, here, I'll work them out just so we have closure on it. But yeah, but if you ask me a question, I would just ask that it's something that you know, just ask me questions for fun or to test me, just like a question that you actually need help with. Honestly, I kind of just want to work with the inside and simplify that before I even think about squaring each side. So multiply by the conjugate of the denominator to simplify it. You get 3 minus 4i plus 6i is plus 2i plus 8 over 9 plus 16. So we get root 11 over 5 plus root 2 over 5i. Oh, and that'll be okay because then we're squaring it in the next step. I can't do what I just did. Can do that. Or I can do, it's fine. So x plus iy squared is equal to x squared minus y squared plus 2ixy, which is equal to this thing squared. And now you can equate coefficients. So x squared minus y squared equals 11 over 25. 2xy equals 2 over 25, like that. I feel like we've all gotten different systems here. Oh, okay, no, I got the same as Fenvox. No worries, Territar. So I guess let's get a sub from this one. x equals 1 over 25y. Plug it in over here. 1 over 625y squared minus y squared equals 11 over 25. Multiply each side. Yeah, okay. Multiply each side by 625y squared. You get 1 minus... Oh, what the heck? What an annoying problem. That, I mean, you can technically quadratic formula that. It just won't be too pleasant. I mean, if you're a Chad, you can figure out how to factor it, I bet. Okay, the polar solution is nice. No, I mean, I think it's still nicer than the polar thing. I was getting like arctan at 2. Miss me with that. 11 plus 2y equals 25x plus y squared. Oh, I think I can see where that comes from. Awful. Not sure what you do with that though. Newbird. Ooh. The square root of the modulus is equal to the modulus of the square root? This site that I have open says it's definitely true for integer ends. I don't know if we could say it for rational, but maybe it holds for certain ones or something. I don't know. Something for your bones crippled? No worries, Paul. Take all the breaks you need. And hey, Soldoy, can we ask any question related to math? Yes, you can. With the caveat that I can't answer every question related to math. And the emphasis of this is homework help. So if you're just going to ask a question for fun, I may or may not try to answer it, but you're welcome to ask whatever. My response, I guess, depends on the question. The square root always takes the square root of the modulus radius of the circle the number lies on. So it is okay to do that. If we could use that, then z equals x plus iy, looking for the modulus of z to the fourth. Okay, so I tried putting these into exponential form, but like I was getting arctan 2 and arctan 4/3, and I figured that I must be doing something wrong. On which books to take for self-studying pure math? Oh, That's a good question that I don't have a good answer to, because I actually, ironically, I majored in applied math. And even then, I don't really know much about math textbooks in general. What I can tell you is you could try another person who's going to do his first stream on YouTube pretty soon here, Zach. I'm not sure exactly when, but sometime in the near future should be doing his first YouTube stream. He normally streams over on Twitch. You could try him. He might have some suggestions. And if you have Discord, there's a pretty big math Discord server that has a place for discussion, like to ask for textbook recommendations and things like that. So you could try making a post in that math Discord as well. But I'm not very good with textbook recommendations. It's Coverstone Corner, the person who I linked in chat. I'm not sure when his first stream is going to be. 1/25 might be the answer then. I mean, I'm going to let Wolfram Alpha do this. We can figure out what y squared is right now. Um, 625. I'm going to convert that quartic into a quadratic so Wolfram Alpha doesn't take the square root for us. Because we don't want to take the square root. Yeah, no worries, Holdoy. Sorry, I couldn't give you a better answer. That's our y, or these two are, well... That's our answer for y squared. We figure out what x squared is based off that. I don't know if we throw out one of these solutions. Like, when is the square root of a complex number, is it always defined? Because there's two different signs in a complex number, so I don't know how taking the square root, like, you know, a negative complex number isn't really an easy thought. The module of z is 1/√5 by the given. Oh, do we even have to worry about the angle? Dude, I don't know. I'm sure there's a trick. Yeah, so I just the entire thing of having the square root of a complex number kind of weirds me out as someone who's very inexperienced with complex numbers. They matter with multiplication and exponentiation. I guess why I'm saying it might not matter is because the task was to find x squared plus y squared squared, which is like a modulus, but I'm not sure. I ask you guys, is any calculator allowed in US university exams? A younger relative who finished A-levels gave me his FXCG50. You don't want to buy another calculator if you don't have to. I want to say that the university I went to allows you calculators. Maybe it depends on the class. They stop being helpful after a certain point. What did they do? Maybe they didn't allow a calculator the more I think about it. Calc 1 allow places of either a split exam system where you have a portion with no calculator and another which allows. Okay. That sounds kind of familiar too, where it's part of your exam you can have it, part of your exam you can't. I feel like I've taken a test like that. I think, Joseph, it's just going to depend on the school and the professor. The unfortunate thing is that there's often some encouragement to specifically get the TI 80 whatever calculator specifically. But you can, if you're willing to look stuff up for yourself, you can usually get by with other calculators. My institution said, make your exams such that having calculator won't matter. Yeah, I feel like that, like if we ever were allowed a calculator, it was for the pretty early on classes. And they just stopped being helpful for a lot of classes. So 1/25 does work. Oh, did Bluebird? The modulus of z to the fourth. Or was there something posted that I missed? I don't know. I'm still weak with complex numbers. I don't know. The modulus of z to the fourth is probably helpful, but I don't know what to do with it. I don't know though. The person who posted the question hasn't chatted in a long time, so I assume they're not still around. I mean, I guess you're taking that thing under the square root and squaring it twice. So all you're really doing is you square that fraction and get the modulus, or get the modulus first and then square it, I guess, like you're saying. Oh, so like the mod of the top one is root 5, the mod of the second one is just 5, so it's root 5/5 squared, which is 1/5. I guess that's probably the easiest solution if it works. But I don't know. You know, I would much rather factor 625y to the fourth plus 275y squared minus 1. Ugh. Been some tricky problems. Five plus 0? Oh no. Man. That's rough. You know, the problem with the sum of powers of I. Oh, okay. A neat way to do it came across recently. It's a geometry series with common ratio I squared. It works on complex numbers? That's kind of cool. But wait, and does that end up in division by 0? Because it's the first term over 1 minus r. And r is I squared, which is -1. No, is it 1/2? That makes no sense though. If it alternates 0, 1, how does that ever become 1/2? I think for the person's situation where it was always a finite sum, the response that I gave like is correct, where you're just fluctuating between 0 and 1. I hope it is. But yeah, getting an answer of 1/2 seems kind of crazy to me. Maybe complex numbers are just that crazy, but geometric series complex numbers. Oh, would the finite sum formula get a better answer? I mean, it doesn't converge is the issue. When does a complex geometric series converge? It still gives 0 and 1? Oh, okay. Was x squared plus y squared root 21 over 7? I don't... The answer that I came up with was x squared plus y squared is 1/5 for that last complex number problem. I don't remember if that was right though. My brain is slowly crashing. 1 minus z to the n plus 1. Oh, okay, so yeah, if you're finite, you still get... It would have to not depend on n in some way. Or... I don't know. Okay, well, that's cool. They still work with complex numbers. I wonder if the modulus... Oh, yeah, it converges for the modulus being less than 1. Isn't the modulus of that exactly 1? Shouldn't this diverge? Oh, and it does that. Like this... You would say it diverges because the modulus isn't less than 1, right? Before you even apply this formula. Finite sums always... Oh, you're right. Okay. The infinite... Okay, okay. Yeah, that's fair, $10. No one tells Zach that I just said a finite thing can diverge. Your secret is safe. Good. I still want to tackle this number 11 problem. Hey, Ronald. Yeah, Joseph found a solution. If you have a different one, I'm interested to see it. I'll bring up the solution that was posted, though. And if yours is different, I'll see if there's a different approach to this problem. Hey, Arcacione? I'm assuming that's Spanish since you have SEN of 9x. That's a tricky one. Cosine of 4x times sine of 9x, integrating that. Huh. Approximate the square root of 2.6? I think this is the golden ratio. I guess it looks like the golden ratio. I should actually plug it in before I just start saying stuff. I forget if the golden ratio is the minus or the plus. I feel like it's the minus. I don't know why, though. Nope, it's the plus, if it is the plus. Yeah, the plus is the golden ratio. Square root of 2.6. All right. Let's see if that's about right. Oh, wow, that is a decent approximation there. Oh, interesting. Okay. It's the sum of sine formula you don't know how. Ooh, well. Huh. Because we could technically apply this formula right here and call like your first one 5x. We could say that 9x is like 5x plus 4x. The 5x is still going to be something that's annoying to deal with. This might be a better thing to use. Actually, this is definitely the identity we want down here. I think we'll get something that we can actually integrate with this. So yeah, if we do the product to sum, I think this will be like a 2 or 3 step integral. Let's go and try it on the board though. So you want to integrate cosine 4x times sine 9x dx. And sorry, in English, sine is sin. So I tend to write it like that, but sin, sen is the same thing. Yeah, it's not used too often, but it's called product to sum. Sine theta cosine phi. For these integrals, I think it's the easiest. It's just the easiest one. Sine theta plus phi plus sine theta minus phi. 2. Okay. So this thing up here becomes sine of the 2 angles added, which is 13x, plus sine of the angle of sine minus the angle of theta, which is 5x, over 2. There we go. And now let's split this fraction up into 2. 1/2 sine 13x plus 1/2 sine 5x dx. I'm going to do a mental use of on each of these. Just divide this first one by 13 to get 1 over 26 negative cosine 13x. This one gets divided by 5 because of the 5 there. So 1 over 10. Oops, that's a minus as well. Cosine integrates to minus cosine. 5x, oops, plus c. So yeah, if you don't know that identity, it gets very tricky. If you do, though, it's a pretty short problem. I wonder if you... I think you can get these formulas like from these sum of difference identities if you tried hard enough. But yeah, that's how I would do it. Let me just plug it into Wolfram to make sure. Negative 1/10 cosine 5x minus 126. Okay, cool. Got it right. Ooh, that's a funky wave right there. Try to demonstrate the one you know. Okay, fair enough. Yeah, if you want to have a copy of it for yourself, that's the link right there. Hey, Yo Zappin, I have a bachelor's in applied math. No, I graduated a few years ago. I have been a tutor in a tutoring center, but right now I'm pretty much just unemployed and doing the stream for fun in the meantime. Put in the square that Joseph. Yeah. Really nice, like a technique. No worries. Okay, I feel like I have the idea of this number 11 problem. It's been bothering me the entire time, but you know, math has been calling. Yeah, it's a little hard to keep track of, especially with Joseph. That their name on YouTube is written in Greek letters, and they just like told me their name is Joseph. So I was like, I have to like remember it, which is fine, but I get mixed up too, is what I'm trying to say. Okay. So we're going to do the infinite case. Distance r away. And we're interested in the contribution of potential from that little bit of wire there, just arbitrarily. Call that distance dy. The entire distance y. So the distance is root r squared plus y squared. So we would say that phi, the potential for the infinite wire, we're going to integrate, I guess, in terms of y. So y goes minus infinity to plus infinity of lambda times the length is dy. That's like the charge, I guess, over 4 pi epsilon naught r, which is root r squared plus y squared. Is that right? This feels more right. How does this thing integrate? It's going to be some version of arc sine? No, it's a sine sub, but it doesn't result in arc sine, does it? It might result in arc sine. Or arc cosine or something. It feels wrong to get something with trig functions though, right? I feel like they would use a Taylor series here or something. Yeah, I think it's a tangent. Well, I think tangent is when there's no root though. You haven't started the integration part since you have no idea what's happening. Yeah. This is It's some tricky stuff. I do want to look back at that disk example and see how similar this looks. dq, they say, is sigma 2 pi s ds because they have a whole ring. I just have a little one-dimensional length, though. So I think I'm fine in saying lambda dy. All right, yeah, let's let Wolfram Alpha do this sub for us. Oh, what is that? A complex value, what? Oh, there's a minus for it to be sine, arcsine or arccosine. That sucks. Surely the book doesn't expect us to integrate this. Or, you know, they provide it in one of their appendices, right? Is it Appendix K? Ah, integral table. This is what we want. Here we go. ln of that thing. Or ln of root x squared plus a squared plus x. I'm going to write that down on the board. That's good. ln root r squared plus y squared plus y squared. Oh, just y, not y squared. All right. Integration is much easier with a table. You recognize those arc function derivatives? Nice, nice. They're pretty annoying to prove, but I mean, if you know the trick, it's not that bad, but they can be a bit weird to like deal with. Okay. So that's the result we get for the integral because everything else are constants. Because we're bounding this from minus infinity to plus infinity. And already we're going to get ln of infinity. That's bad. That diverges. It's expected. Frowny face means diverging. Oh wait, they probably want us to use a Taylor series for this part also. Or maybe not. They maybe want us to use Taylor series on that. But the second case, we're going to take a finite wire of length L or 2L. So we're going to integrate from minus L to positive L. And the same exact thing otherwise. Do I need to stick a negative sign in front of this? No, we don't do that yet. From minus L to L, lambda over 4 pi epsilon naught, ln what do we get here? Root r squared plus L squared plus L minus root r squared plus L squared minus L. So the roots actually cancel, don't they? Isn't this constant? Dude, I gotta use the bathroom. I'm dancing. Wait. I'm gonna be back in a second. I'm sorry about this. Okay, sorry about that. And yeah, Finbox, you're right. For whatever reason, I put this divided from minus L to L on the inside of the ln, and I have no clue why I did that. Yeah, it's outside. We can just modify the answer using the log identity that you point out. R squared plus L squared plus L over root R squared plus L squared minus L. Surely this thing simplifies some way somehow. That might be a Taylor series thing. Maybe we want to multiply by like the conjugate, like rationalize the denominator. Let's try that before we go to a Taylor series. R squared plus L squared plus 2L root R squared plus L squared. I don't know if this even helps. Just R squared on the bottom. I don't know. I don't know if that's cleaner or not. Taylor series simplify the result. Then take the derivative. Let's see what Taylor series they give us, because I assume they're going to have some kind of pre-built Taylor series here. What? I don't know what that is, Fembox. Cannot be simplified with X, maybe? I don't know. Joseph. I don't know what that form is, I guess. Divide top and bottom by R squared. For my last line? Yeah, I guess we can apply this Taylor series if we do that. Is what you're saying? It's probably not zoomed in enough. Okay. Yeah, that's fair. Let's do that. X plus y over x minus y. I might be missing a step there, Joseph, but I just don't see how that works. I think we have a promising route forward here with what Fembox was suggesting, though. Just we divide all this by R squared, so we get 1 plus I mean, I guess we can keep the rest. 2L squared plus 2L root R squared plus L squared over R squared. And that's what our Taylor series ing. Lambda over 4 pi epsilon naught. So I forgot I had that alert. Fucking shit. That's unfortunately timed with me being off camera. Right as that popped. But yeah, that definitely surprised me. Oh, that was an I or an L. Okay, I thought it was an I, and I was really confused. Seeing an I and an R made me go back to complex numbers. Thank you, Hardlocked. For both the bits and the complement on the cat. I can't talk. So ln of 1 minus x. So everything there is negative, but we have 1 plus x, so everything's going to be positive. I don't know how many terms we're gonna take. Prove that 3 plus 2 root 5 is a rational, kiddo? I forget how those proofs work. I'm sorry. I think you assume it's equal to a over b, where a and b are integers. I don't remember how you get the contradiction, though. It's been a long time since I've seen a proof that a number is irrational. So it's x, which is that monstrosity. It doesn't feel like much of a simplification, but... Can we just take a one-term approximation here, or should I go out to 2 terms? Sure. We're going to take the derivative of this. There's no way they expect us to take the derivative of that, right? It's impossible. Physically impossible. Oh, I don't know. I'm just going to take a one term. This feels like it's still way too complicated. Is there something better I could have done? Because this derivative isn't going to work out to anything that clean. And we know the result we should get. Yeah, there must be some more simplification we can do there. Wait, that's just a binomial expansion. Oh, I guess that is a Taylor series. Okay, that's fair. Wow, that's a weird connection I just made. Anyway, if we have like root x plus y over root x minus y, what does Wolfram do with that? It's still pretty ugly. Oh, should we have kept the logs separate and done 2 different approximations, and then we get cancellations? Oh, but how do we get the 1, though? We could do a +1 minus 1. This feels like cheating, but let's keep the logs separate and hope that something cancels. Because I don't think they expect us to do a derivative that difficult. We're supposed to get... I think this is supposed to boil down to be just an R, to be the formula for field for an infinite wire. Okay. Now, on each of these logs, let's do the first term. Well, it's going to be a secret +1 minus 1. Don't tell anyone about it, though. Um, 4 pi epsilon naught. That one, so the plus one is like the part that's over there that we don't care about. The minus one, it is going to stick with us. Root r squared plus L squared not equal to about plus L minus 1 minus root r squared plus L squared minus L minus 1. Please someone get cancellations here. The roots cancel, the 1s cancel, the L's combine to 2L? Oh wait, we want a dependence on R though. No! This is annoying. Why doesn't it just work, you know? Is this be another R somewhere else that I'm not thinking of? I don't think so. I mean, this looks familiar. But we would have ln of that thing. I feel like I'm so close on this problem. I'm just missing one piece. Wait, let me look back at one other thing. Let me just make sure that I am expecting the right result for this. Yeah, Fembox. So I guess I was looking for the field due to an infinitely long wire. It is this thing. We expect to get something that derives to this thing. Because the derivative of phi with respect to r is field, negative. And we want something that's going to derive to this thing. So we do want some type of ln of r. Try the whole thing in terms of L over R. That could be it. It differentiates. Ugh. I can't math or English right now. Because I think ideally we want to get rid of the L's. Oh, wait. If we want this to approximate an infinitely long wire, you would want to be very close to that finite wire. So R would be much less than L. But I'm just getting, so that becomes about 2L, which I just like found the Taylor approximation. If R is much greater than L, they still cancel. Approximating the roots instead of the logs. It's worth a shot. I have no clue what page it was. Could use another system? Like, what do you mean, Paulo? Oh, yeah, that's the wrong appendix. Oh! They give exercises to just find the divergence generically. Oh, that's kind of cool. There's exercises in the appendix. That's kind of sick. Okay, anyway. Short review of relativity. I'm going to need that. Thank you, $10. If you just wanted to approximate the roots, that's probably a better bet, right? I need to get this appendix. Actually, I don't know if the audio's coming through. I just took a screenshot and that like freezes the screen on my end. But I need to get this appendix as like a separate PDF, I feel like. So I can have it open at the same time as the problem. Paulo, the problem I'm about to bring back up right here, it's number 11. I think we have the right integral. It's just the approximations that I'm not making the right approximations, evidently. I'm gonna scale it down. This problem's a big boy. I'm working on the second part of it. I probably shouldn't have erased that. I still want this here, I guess. The two separate ln's, because I think we're going to do it separately. It's a weird bracket. See, if we had just approximated the square roots, how would... How would that look? So root 1 plus x is 1 plus x over 2, if we just keep it to like that first order. So we'd want to factor an L out? One plus x over 2, and that's our x. I think like that. Can we factor a minus L? Question mark. Yeah. One minus root r squared plus L squared, 2. Does this become anything that's even slightly nice? Isn't ln of negative L a bad thing? We try to put the minus sign back inside now that we've done the approximation. But we can get a cancellation of ln L and ln L, right? It's a lot of L's. So I'm going to do a lot of mental math here. I'm going to say ln L cancels with ln L. The negative sign needs to come back inside before I can do that. Okay. Is this possible to do anything with? Oh, shoot. When I factor the L out, an L needs to come into the denominator here. Same there. How do you do this? This doesn't... This still makes very little sense to me. It has to be the same. Is it though? Writing all in terms of L over R. Y equals R tan theta. Because Y has, to me, very easy to see limits. Theta doesn't. It's gonna be some dependence on L, I guess. I mean, maybe. If you integrate that in terms of theta, what would you be between? Isn't there could be some inverse trig involved? I'm not sure, Paulo. I'm sure I did this part right. Opinion on Terrence Howard's mathing? Not a fan, personally. I did watch that Neil deGrasse Tyson video, which was about as polite as you can make that message, I think. He's convincing with it, though. I didn't actually listen to Terrence Howard's pitch of it, to be fair. But based on what Neil deGrasse Tyson said, a lot of the stuff he said is just verifiably wrong. Because they're integrating with respect to x here, but we're integrating with respect to y. It's really just a letter. We could name that the x-axis as well. But I mean, I applied the formula right, as far as I can tell. It's gonna bother me. I'm getting close to the point of just looking at the at the answer. Ice for a hint. Yeah, I don't think there's anything wrong with like hearing him out. Nimbus either. I agree with that. B plus R. Yeah, that keeps on, because like for the setup of the integral, we're treating R as a constant, but then we're gonna, like the next step is gonna be to turn around and treat R as the variable, which is tripping me up. But yeah, no, I mean, I think you should always be able to hear out someone who has an opinion that you don't agree with, and try to like honestly consider it. Okay, I'm gonna pull up the answer. I'm only gonna look at like the very first part of it though. I set up the integral right. Oh, you used cinch to prove that integral. Wow. Oh. So my messy ln thing with a square root plus L divided by a square root minus L matches the book. Okay. Now, all I've read further than that is they're doing the limit where L is much greater than R. So let's just let's back this work up. Oh, so I have a channel point redeem to make me draw stuff. And so this drawing over here was to draw me as a stump. And this drawing over here was to draw Waffle, Walrus's cat. Because Waffle was in chat earlier. But yeah, that's me as a stump in the middle there, is the moral of the story. Okay, so from this point, they do L is much bigger than R. Which I think makes sense to do, because you want to be up close and personal with this finitely long wire. But that isn't what I was expecting to get. I mean, okay, this is this wasn't gonna be, if R is much greater than L, or L is much greater than R, aren't we getting L plus L over L minus L, which is 0? What? Yeah, tree stump. Oh. Fembox, you're right. R over L. Okay. What they do, I only took a very brief glance at it, but they looked at approximating just root R squared plus L squared. Do I still have that approximation up? 1 plus x over 2. Oh wait, factor out an L. L root 1 plus R squared over L squared. is about L, well, we can just multiply the ln. It's about L plus x over 2 plus r squared over 2L. What the L? Am I right? You couldn't get the damn thing to work? It should work, apparently, because you have to approximate literally just the square root bit. Apparently. L minus L is 0. The r squareds are canceling. No, they're not. I can't do all this mental math at once right now. Do it slow. Four pi epsilon naught ln. Unflip the fraction, multiply it in. 4L squared over R squared plus 1? This doesn't seem right, though. Still. Because I want to do L much greater than R on this. But that kind of, that's like, it's blowing up. Okay, I'm going to peek a little bit more at the answer. Oh. Wait, did I do my math wrong? Wouldn't be the first time. Or the last time. L plus R squared over 2L. They already took the, as soon as you do that approximation of the square root, that's the L is much greater than R limit, apparently. But Taylor series probably only works for a certain radius of convergence, I guess. I'm not getting the same simplification inside the ln, though. And I can't figure out why. They get just 2L over R. Where's the +1 go? I figured out part of the issue. Yeah, I am nearly there. The +1 is the only difference between my answer and the book's answer. And I don't know why. Maybe that's another approximation thing. Oh, to leading order, they do just drop off the +1. Yeah, okay. It's a classic physics. We don't care about or like that +1. We're not gonna write it. And they also notice that that's a perfect square, so they take a 2 outside. I'm going to cancel with the 4. 2L over R. Now let's differentiate that. That's our phi of R function. So minus d phi dr. What does that give us? 1 over whatever that thing is. Over 2L chain rule times minus 2L over R squared. The twos, should you, oh, those two, okay, the 2L's cancel. Oh, lambda over 2 pi epsilon naught R? I think that's right. Oh my God. Physicists doing physicist things? Yeah, it really is, Joseph. They just chop off terms for fun. That disturbs someone who mostly studied math. Oh my God, it's right. I'm going to show the answer. Take the log of a dimension full quantity? I don't get why it wouldn't make sense, but okay. That's just a fact. It's a formula that the book gives. E is minus d phi dr because positive work is negative field, but yeah, the gradient in cylindrical coordinates reduced down where we only care about R. There's no angular dependence or z dependence. And you're right, yeah, the gradient, or there's a couple of examples in the book where the gradient just simplifies down to like a simple ordinary derivative like this. Like the gradient of a single variable equation is just a normal derivative, except you slap a vector on it too, technically. This feature of truncating the wire is valid for the following reason. So the field from between charge falls off like 1 over R squared. The field from a very long wire is essentially equal to the field from an infinite wire. Interesting. The field we found for the above finite wire is essentially similar to the field for the infinite wire, provided L is large enough to make the approximation valid. You can take them as L goes to infinity and nothing changes. Okay, fair enough. Right. Here they say the scalar quantity E of R. In that disk example I was looking at, they do R hat. So in my work I did on the board, I did leave off the r hat because I'm lazy. But you're right, it should be there. Potential depends logarithmically on L. The field is independent of L. Potentials all change by the same amount. Oh. Changes by the same amount every... Huh. That's kind of a neat metaphor. Analogy, sure. It kind of hurts my head, this last paragraph, but providing sufficient proofs instead of just saying effectively equal makes no sense. Challenging. With by another 2-star problem. I feel like I got the important bit, which was setting up this integral here. I'm willing to excuse myself on the approximations bit, because I never had to do that in this way before, and I think it's just going to come with practice, so I don't mind getting my ass kicked there, I guess. Eventually, I'm just going to figure out the patterns of when you want to take what approximations and with what piece of the formula, but until then, just got to take my lumps. You can... Okay, I think I'm going to wrap things up there for the day, though. So I'm going to end the YouTube stream. On Twitch, I'm going to go raid out. But everyone here on YouTube, I appreciate you. It's been a good YouTube day. YouTube is pretty variable, but Joseph, thanks for being here. If anyone else there on YouTube, thank you too. I'll be back on YouTube on Saturday. Yeah. All right. Goodbye, YouTube.